So now I'm going to go over some problems to show you how to run a hypothesis test for proportion. You can use your calculator as well to follow along, and I'm going to provide a document on ReggieNet that shows you how to use a TI-83, 84, or 89, and those documents show you how the commands that you should be entering to run a one-sample z-test. You could also Google a one proportion z-test for whatever calculator you have, a TI-83 or 89, and there's plenty of videos out there that also show you how to use your calculator to run this test. You can't use Excel because the z-test in Excel is for means, and we haven't covered means yet. We'll do that for the next exam, and so for now, just leave Excel to the side. You can use your calculator, or you can just do it by hand, but your calculator might save you some time. So here in this problem, we're looking at a census, and it found that 16% of people in the U.S. are Hispanic. However, in one county, the supervisor there believed that her county has a smaller proportion of Hispanics, and she sampled some of the people in her county. So she sampled 493. She didn't sample the whole county because that would be too time consuming. She just sampled a few people, and she found that 60 of them are Hispanic. So when we calculate that sample out, we found that in her sample, only 12% of the people were Hispanic. And so what we're interested in testing is if her county actually has about the same amount of people as the U.S. does. So is her county 16%, or is it in fact less than that? And so our alternative hypothesis is that her county has a smaller proportion of Hispanics than the national average. Now you can see that our sample percentage is lower than the hypothesized value, or it is lower than the national average. However, samples vary. So maybe she just happened to get a sample that's smaller, and if she were to resample, she would get a value that's higher. So we want to test to see if this is statistically different than 16%. If it's statistically different than 16%, then we can conclude that we have evidence that her county is in fact smaller than the proportion. So there's one of two possible conclusions. We could fail to reject that null hypothesis, and we're going to assume a 5% significance level. If we fail to reject, then we find no evidence that the Hispanic population is lower than the national average. However, if we reject the null hypothesis at the 5% level, then we do have evidence to suggest the Hispanic population in her county is lower than the national level. So let's go ahead and run this test. Ultimately, what we want to find is the p-value for our sample. So our sample is what we start with in the z-score. We want to see how unusual our sample is compared to that null hypothesis. So the null hypothesis goes second, and we use that null hypothesis to generate our standard deviation term here. So that's just the square root of our p naught times 1 minus p naught. So this 0.84 is just 1 minus 0.16. And then we divide by our sample size. So we take into consideration how big of a population that we are sampling. And that's going to give us a z-score of negative 2.30. So you can see, because this is greater than the absolute value of 2, that we have a pretty unusual sample, or that we've made a bad assumption. But we want to go one step farther and actually calculate the p-value for this z-score. Now to calculate the p-value, we want to go back to the hypothesis that we generated. Remember, the parameter of interest here is the proportion of Hispanics for this county. We don't know what the true proportion actually is. We only have a sample proportion. So we're going to look at how unusual our sample is if the true proportion is 0.16. So we're assuming the true proportion is 16%. And then we're going to try to find evidence against that in favor of the alternative that it's less than 16%. So our sample is our evidence, and we want to see how unusual it would be under a 16% population parameter. That is the probability that P for the county is less than 0.12. An equivalent statement then, since our z-score for that 12% is negative 2.3, is that the probability of a z-score is less than negative 2.3. Now, you know how to calculate this probability from your z-tables or from your Excel calculator. And so you can calculate that probability and find it on the z-table as 0.0107. This is our p-value. It's the probability that we would see a sample that we do if the null hypothesis is true. Now you can see that it's a really, really tiny probability. So either we do have a really unusual sample or we made a bad assumption in the null hypothesis. Since we think we sampled randomly and independently, then it's more likely than not that we made a bad assumption and our alternative is true. So our alternative is that the population proportion of Hispanics for the county is in fact less than 16%. But we need to compare this to our alpha level to fully understand whether or not we should reject or fail to reject. So let's assume the alpha level is 0.05. That is, we want a significance level of 5%. We'll interpret the previous p-value that we just calculated, and we see that our p-value is much lower than the alpha. So we have a lot of evidence against that null hypothesis. Remember, the lower the alpha, the smaller the alpha, the more evidence that we're requiring. And so we have a lot of evidence against that null hypothesis. So because the p-value is low, there is sufficient evidence that the Hispanic population in this county differs from the nation. And we could even go ahead and say that it's less than the national level. The reason why we are able to say that it's less than the national level is because we ran a one-tailed test. Our alternative hypothesis had direction in it, and it specified that we thought the true proportion was less than the national level. Let's briefly try one more problem. In this problem, an airline's public relations department says that it rarely loses passengers' luggage, but when they do lose its luggage, 85% of the luggage is recovered and delivered to its owner within 24 hours. That means of the luggage that they lose, 85% is returned immediately. So they want to test this claim to see whether or not the airline's claim is legitimate or not. And so we can, as a consumer, we can go out and survey airline travelers. And in this study, they surveyed 194 people, and 157 of them who lost their luggage were reunited. So everyone in this survey had lost their luggage, but only 157 of them were reunited with it by the next day. So our proportion here is the proportion of people who recovered their luggage within 24 hours. Again, everybody that we are sampling has lost their luggage. First, we need to set up a null and alternative hypothesis. So we're going to start with equality in the null hypothesis, and we're going to say that the airline's public relations is correct. We're going to assume that the true proportion of luggage losers who got their luggage back in 24 hours is in fact 85%. So we're going to assume they're true, and then we're going to use our sample to provide evidence that that may not be the case. So we're not saying that it's greater than or less than. We're just saying it's different than what the airline claims. And so that's why we're dealing with an alternative hypothesis, that it's not equal. The next step is to find our z-score. But to do that, we need to know the sample proportion. we sampled people in our survey and we said 157 of them were reunited with their missing item. That means about 81% of the people we sampled had luggage that they were reunited with within 24 hours. So that sample proportion goes first, but our hypothesized value goes second, and we again use the hypothesized value to generate our standard deviation, which is this square-rooted term. When we calculate this z-score, we get negative 1.59. So the alternative hypothesis makes calculating the p-value somewhat difficult here because we're dealing with a not equals. So we can't just say z is greater than or z is less than some value because we're dealing with an alternative hypothesis of not equal to. So it's like we're saying we want to know the probability that the true proportion is not equal to 0.85. And that's equivalent to trying to find the probability that z is not equal to negative 1.59. Now, our z-tables give us everything below, and we can find everything that's above, but the z-tables don't give us something that's not equal to. So what we have to do is we have to convert this into a directional inequality, and so that's what I've done here. So when we do that, we have to times it by 2 to make sure we get both the upper tail and the lower tail. So we're using that principle of symmetry in the normal model to find this full probability. And this z probability here, that z is less than negative 1.59, you can use your z-tables for, and you could use a z-calculator. And when you find that and times it by 2, we get a p-value of 0.1118. Now, just to review briefly, when we have a two-tailed test, meaning that our hypothesized value is not equal to the parameter that we're proposing, we have to calculate the p-value using our z-score. And if it's a positive z-score, then we want to look at the probability that z is greater than that positive value, and then times it by 2. But in this problem, because we had a negative z-score, we wanted to look at the probability that the z-score was less than that value that we calculated, and that's why we then times it by 2. So this, again, is the mechanics that we're using to calculate this p-value for this particular alternative hypothesis. So the p-value that we calculated is 0.1118. And this is actually a pretty large p-value. We want to compare this to an alpha level, and the problem didn't actually give us an alpha level to compare it to. We're supposed to determine that beforehand, so most problems will give you some alpha level. But you can see that the most commonly used alpha levels are all smaller than our p-value. So again, we're going to use that criteria that because the p-value is greater than the alpha level, we must fail to reject the null hypothesis. And if we don't reject that hypothesis, then we don't have enough evidence to cast doubt on the airline's claim. We've assumed that the airline was correct, and we just don't have enough evidence to support that it's not true. We can't say that it is true, just that we don't have any evidence against it. In the next set of videos, I'm going to go back to the confidence interval because we know how to create confidence intervals about where we think the true proportion might lie. And I'm going to show you how we can run hypothesis tests using the confidence interval. The results of those tests can sometimes be different than these z-tests, but most of the time they end up generating the same conclusions. And so it's fine to use either of them. But we should also note that sometimes our test results are incorrect. Sometimes our samples are the unusual samples. And I'll also cover what those errors mean and how we define them.